This lesson is part of the TI-Nspire CX2 Technology Student course. In this lesson, you'll learn about arrangements and selections of objects and corresponding calculator commands. Imagine you have a blue car in a single garage. One car, one parking spot, one arrangement. Suppose you now expand your garage and buy a second car, a green one. Now there are two cars, two parking spots, and two arrangements. As a car enthusiast, you expand your garage and buy a third car, a red one. If you leave the blue car parked in the first bay, there are two ways you can arrange your green and red car. Or, if you park the green car in the first bay, that would leave you once again with two arrangements of the remaining cars. Or you could put the red car in the first bay, and again, two ways of arranging the remaining cars. That's a total of 6 arrangements. Now you expand your garage again and add a yellow car to your fleet. How many ways could you arrange your cars? Well, if you put the blue car in the first bay, we know from previous experience there are 6 ways to arrange the remaining cars. Alternatively, you could put the green car in the first bay with another 6 arrangements of the remaining cars. So, with 4 options for the first bay, it follows there would be 4 times 6, a total of 24 ways to arrange all your cars. In general, the number of ways we can arrange n objects can be calculated by n factorial. This is equal to n times n minus 1 times n minus 2 and so on. Arrangements are often used in probability, so you will find the factorial command in the probability menu. So, our 4 cars in the 4-car garage had 24 arrangements. So 4 factorial, which is 4 times 3 times 2 times 1, equals 24. The factorial sign is the same as the exclamation mark, so you can also access it from the punctuation key. Tap the key and tap again, and then press Enter. Now, let's return to the garage and our 4 cars. There are only 2 roller doors up. How many different arrangements might we see? The dots represent a summary of all the arrangements from the 4 cars, but we can't see what's behind the remaining doors, so some of the arrangements now look the same. To calculate the permutations, we can simply divide by the total number of arrangements that we can't see. So that would be 4 factorial divided by 2 factorial. Or, in general, n factorial divided by n minus r factorial, which is the permutations formula. Permutations can be found in the probability menu. The syntax is very simple. The first element is n. Let's say our 4 cars. The second element is the quantity of objects we want to arrange. In our case, the number of cars that we can see, 2. And we see the number of permutations is 12. Let's check out how many permutations there would be if we had 3 doors open. So that would be 4p3. Take a moment to think about why this result is the same as with all 4 doors open. Our final example considers just the colour of the cars that we can see, so we don't care about their order, just the colour. Again, suppose only 2 of the 4 garage doors are open. So seeing the blue car then the green is exactly the same as seeing the green then the blue. Clearly, there'd be even less combinations. We can simply divide our previous quantity by the number of ways of arranging the cars that we can see. This is referred to as combinations. Of course, the combinations command is also located in the probability menu. So, with 4 cars to choose from and just 2 visible, and we don't care about their order, we get 6 combinations. Finally, you may have heard about Pascal's triangle before. The combinatorics command can be used to generate any of the rows in Pascal's triangle. Check these calculations out. Thanks for watching.